Yes, sir.
Oh, okay, let's get started. So we'll talk about creating a class, okay, and we'll have few functions there inside the class, and from main we'll control the class. Okay, so there's one more concept called if name equal to main. Okay, we haven't done modules actually. We're supposed to do more, but we'll do module after we're done with the class. So what happened? Okay, we'll do after we are done with the class. Okay, so let's continue with the class here. So let's say I say class and I say class and math ops, something like that I say. Okay, meaning mathematical operations, and I will add multiple mathematical operations here. Now here I can give first init, right, to initialize the variables. So I'll say def underscore underscore init. Okay, and let's say we take two values. Okay, so we say self comma a comma b. Now sometimes b may not be required, so we will say we'll assign default value to b. Okay, now I'll say self dot num1 equal to a, self dot num2 equal to b. So we got two values. Now how do you create object of this? So to create object of this, you will give a variable name or object name. Now we know that it's not variable name, it's object name. So I'll say m1, okay, equal to math ops. Okay. Now in maths op, okay. Now when you do this bracket, you see here, it gives you the definition. Okay, so if this definition is not in this file, some other file, that's what we'll discuss when we talk about modules later. If this file is in some other file, okay, you cannot go scroll up and see. Still, you'll be able to, you know the definition. So here it says a comma b, b is int, and a can be anything. You can sometimes, if you want to force, okay, user to give integer value itself, you can say a colon int. This is also accepted. So when you say a colon int, that means you are saying a can only take integer value. Okay. Now if I try to create something like this, okay, and when I run this, okay, okay, so it is calling MathHub, and a, which is supposed to be integer, okay, is not taking hello. Since we are not doing any operations, so no, there is no error here or there is no message here. Now I'm going to build an okay, or if you don't want to do that, you can directly call each function. So let's say we'll start with function called as sum. Okay, so I'm going to call it as add. So def add, okay, add, right? Add, okay, and then I'm going to say self. Okay, and add is what? Add is return. Return self dot num1 plus self dot num2, right? And now here if I say m1 dot add, okay, and I say print, obviously you're going to get error, right? Because you cannot add, okay, you cannot add a string to this. So when you give colon equal to, so that, when you try to uh, assign the value, it gives you the hint saying that, see, the value a, okay, should be integer. Okay, it kinds of gives you a hint. Okay, so that's why it is, you can add this so that the user knows, okay, a has to be integer only. So now I give 100. If I don't give B, obviously I'm going to get 101, right? So you can keep on building. Can keep on building these various functions, def, subtract, okay, return. Now, so this is one thing. Now let's say instead of return, you want to assign a variable which can be directly called here. So let's say add and subtract. What I did, I created a function and I'm returning the value. So when you call this, okay, you have to call the function here, right? So you get 99. I can even declare, okay, let's say self dot multiply, okay, equal to, I'll put -1 inside in some value, okay? You can say, let's say div equal to -1. Now I create still not recovered fully, guys. Excuse me for that. So now let's say multiply. Okay, so I'll create function here, def. We'll call this as okay, and function will call multiply. Let's see. Def multiply self, okay, and here I'll say self dot mul equal to self dot num1 into self dot num2, right? Now, in these two cases, see, I'm not returning anything, right? I'm just assigning the value. So if I say print multiply, what will happen? Okay. So if I say here, what will happen? Nothing will happen. Saying none. Since we are not returning anything, it is returning none, right? Okay. But to initialize these values, right? See, if I do not initialize, I simply call this. So I'll say print m1 dot multiply or mul, right? So mul is variable, object variable. So simply I call mul here. So it'll give me the value here, 100. 100 into 1 is 100. But let's say if I forget to call, okay, if I forget to call the function and then I call this variable, what happens? You get -1 because that's the initial value. I'm calling it before calling this function, right? So I'm just telling you different ways of accessing these values. Now let's say if this is just one line here, okay, let me say square. Self dot square equal to self dot num1 star, or let's say not square, let's do square, okay, and then we'll do dot power equal to self dot num1 star self dot num2. Okay, now in this case what I did, I'm directly assigning it the values in the init, okay, because since it's one line I can directly do it, right? Now in these two cases here, I can directly say print m1 dot power, let's say print m1 dot square. in this case, I don't have to call any function. There is no function, but in the init itself, I'm defining the values here. So you get square, 10 square, and no, it's not 10 square. What did I do? Num1 is 100, right? Oh, first I did power. So 10 to the power of 1, correct? And this is your square, right? 100 square. Okay. So this is how, you can use using return. If you say return, you have to, get the value here. So you can say here, division equal to, okay. And then you print, right? Right? You have to call the function and then store it in a variable because we say return, right? So whichever is easier way, you can implement for your program, right? Okay. 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 Now we'll talk about the various properties of class and objects. Okay. What are different properties and how to um, work with those properties. And then maybe we'll take some similar examples for doing that. Did you understand? This is how you can create different functions, okay, initialize variables and use it. Any questions so far on this?
No, sir.
No. Okay, good. So let me go to class and objects. Yeah. I'm going to share my notes 1 second. Okay, so see this. So we know class and objects, right? So we don't have to discuss. So class and objects are the foundation for object-oriented programming. We call it as OOPS, okay? Class and objects are the foundation for OOPS. When we say OOPS, it is a way of doing programming where you put object at the center, okay? And that's how really it works, right? Now, if I have to look this as a non-class and objects, we say procedural program, where we use what the we use only procedures or functions. So it's like, okay, this is training. Everybody come in, do the training, and then we all go away, right? But uh, that's a procedural form of procedural, right? It's a function. We come, training is a function. We all are here, and then we all go away. Then let's say, you might go for a movie, so that's a function. Go for watch movie, everybody goes away. But in reality, that's not true, right? We all are individual, right? We don't disappear after training is done. We have something else to do. So we create an object for everything, and that object behavior we capture. Yes, sometimes they'll have functions, sometimes we'll have variables. So they said that procedure is it's not going to work. We are not able to reuse the properties. So you create objects for training, and then it goes away, right? So again, if you have to do something else, again, I have to create properties, right? So once you create the property and use it whenever, wherever required. So that's when they came up with this concept of OOPS. So we have already seen class and objects. We are going to look at 4 other features, okay? What does this mean? The first feature is called abstraction, okay? So the purpose of this is that when you create class and objects, as a user of class and object, when somebody uses, they don't have to know the implementation. They don't need to know the background of the, how things are working. Okay, that's what we call as abstraction. Here, if you are a driver of a car, right, you don't need to know how engine works, how they are fitted together, and you just need to know how to use accelerator, clutch, brake, and steering wheel. That's it, right? 4 things you need to know. You don't need to know inside how it works. So similarly, when we do append, okay? Or when we do copy, we just need to know what input it takes and what output it gives. Functionalities. We don't need to understand, how append does what it does, right? How copy does what it does, right? We don't have to get into the details. So somebody has written it once, okay? So one person has written it, and millions of us, we just use it. We don't have to get. So the purpose is, as a driver, your job is to take the passenger from point A to point B, right? You focus on your task. You don't worry about other things, right? So when we understand append and we understand copy how it works, our focus is to build our application. Okay, we don't need to sit and understand what's happening behind, but we focus on building our application, right? That's the purpose of abstraction. So abstraction is the important feature, and that's why class objects are based that. Yes, you define it, and then you forget it what is there. You just focus on what output it gives. Okay. So it says, example is the car, and as a driver, you only need to know few things. You don't have to get down into the details of interior. Then second property is called encapsulation. So in a way, we have done abstraction, right? In a way, we have done abstraction. So when we call multiply or when we call division, we didn't need to know what formula it is used. Then comes encapsulation. Encapsulation is for security. You don't want to expose all your variables. So far what we have done, we have actually, every variables that we have declared is accessible by the main program. So in OOPS concept, like if you talk about Java or C++, they have three concepts. One is called public, private, and protected. So every variables or every function, it applies for both functions and variables. They can be public, private, or protected. Okay. Okay. So public means anybody can use those variables or a function. It can be called by anyone and everybody can use it. So what we did in our example yesterday, or even today when we call those variables, directly we call multiply, self.multiply, right? Or self.mul actually. Directly we call. So it is a public, so it can be called directly. Then private is that you cannot call it outside the class. Okay, you cannot call outside the class. So for example, if I go back, okay, to the program, okay, I'm on a programming screen. Okay, now let's say I define this mul as private. Private can be used only within the class, but not outside. I'm calling this mul, right? Yeah. So what I'll do, I'll make it private. How do you make private? By adding double underscore before. Okay. When you do not add anything before, okay, sorry, this is self. Variable is this one, right? So when you add double underscore before the variable, we are making it as private. Now, private variables cannot be used outside the class. Okay, double underscore. Okay, when you do not have any underscore before, it's public. So by default, it is public. If you want to make it private, you have to add double underscore. Then we have protected. Protected will be used when we do inheritance. We can see it. Protected members now are defined as with single underscore. Okay. Now, one more thing is that concept is there in Python, but it is not enforced. So Python actually has only private and public. Protected is not there. Concept is there. That means I can define something as under single underscore, but it behaves exactly like public. Okay, so we have division right here. Let me make division. Uh, Division is returning. Okay, power M1, right? So let me make it protected. Okay, so protected. This is protected, but it behaves like public only. Protected says that only the classes that is inheriting should be able to access it, not everybody else. Okay. So now, okay, so see, there is nothing called null. So if I run here, it will say has no attribute null, right? Obviously, it doesn't have because we have added double underscore here. Okay, so it does not have null. So here also, now when you try to run it, see, okay, when you're calling in the main line number 22, it says no attribute because till here it is applicable, it is part of function. So till here it's fine. But here it is not available for us to access. Okay. Now, if I say here, return dot mul, okay, and I'll comment this out and I'll call this multiply. Okay. So see, power, because power is what we gave as single underscore, right? Protected power. Yeah. So do you see? There's multiply. So value we are able to return. Okay. So when you say return, value is being passed to the main function, but variable as such is not applicable, is not available. Right? This is what we call as private. In class, it can use it. You know, multiply, since multiply is a member of class, it can use this private. But here we cannot use it. Instead, we can, we can ask it to return. So it is invisible to us. Okay. It is invisible outside the class. The class will have multiple variables and functions, but only few will be exposed to us. What is not exposed is used for internal calculations, right? For example, right? Let's say, you think of this as like, your home and public, right? Now, you will not show everything to the public, whatever you have. Okay. So whatever you show to everybody, that is public. What you hide and you don't show to anybody, that's private. Okay. You might have your relatives coming in, visiting you, your friends, relatives. So there is some extra thing that you will show to them. That's called protected. The families and friends that relatives come to you and you'll show something extra to them, that is protected. So protected can be shown to your family and friends, but private cannot be even shown to them. Okay, those things which are private, we will not show even to them. Okay, so we haven't done the relative friends so far. We'll do that tomorrow. It's called inheritance. Okay, we'll talk about it, but today, okay, in some time. So at least, did you understand public and private? Private, you cannot call it. And if I do here m1 dot, okay, you can see num1, num2 squared, div, and inner divide. Okay, but you won't be able to see double underscore mul. Okay, you won't be able to see double underscore mul. But here you see, you are not even able to see double underscore power is not shown. Okay, double underscore power is also not shown, right? But you can call it. This is why we say, okay, protected concept is there in Python. Concept is there in Python, but not implemented. Means when you say if it is available, you should be able to see, right? So you are not able to see. But when we call it, we are able to get the value. So since we are able to get the value, it is not implemented. But concept, it is there. That protected thing cannot be shown to public. The things which are protected only for family and friends, you don't show it to everybody else, right? So that's why it's not seen here. But when you try to print it, you will get the answer. So it is not implemented. Okay, so remember, private and public and private are implemented. They behave as they're supposed to behave. But that protected concept is there, but it is not implemented strictly in Python. So it behaves, okay? It be in output, in practical sense, it behaves like public only. Okay? Understood what I was saying?
So could you show an example with public and private?
I showed you, no?
Could you go through it again? I didn't
Yeah,
understand.
yeah. So I just told you, right? This is not going to work. This is private, right? So if I try to access m1.mul, it will not give you. Line number 23 is giving error. So it's private, so it's not able to access. You are not able to display. You are not able to print it, right?
So
Earlier
how
we were able to. When it was public, we were able to get it.
so how can we access it?
You can't access it.
Oh, then what's the point of it?
The point is that I want to I want to see your contact list.
Mm-hmm.
Do you will you allow me to see your contact list?
No.
No. So what's the point of having the contact list?
Okay.
It is for your internal consumption, isn't it?
Mm-hmm. Okay.
It's for your private consumption. So you can define it for your internal consumption,
Okay.
right? You can use it wherever you want to. You can, you can use it here. It's all, so within class, it's all fine. Okay, you can
Okay.
use it here. This is not throwing error. You can use it inside the class.
We just can't call it. That's it.
You
Okay.
can't call in the public.
Okay.
You can't call it outside the class.
Okay.
Okay, so things which are private to you, only you can access them. Okay, so if you want to talk to your friend, you call, you can, you can use a contact list, but you won't put your contact list on blog post or somewhere, because you
Mm-hmm.
don't want public to see your contact list, right?
Yeah.
Something similar. So you can only use it for your own purpose, but not outside. But there is a way to do it, right? So it is returning the value. It is returning the value. This is not the variable. Okay, this is not the class variable, object variable that I'm getting.
Mm-hmm.
Returning, and I'm saving and I'm displaying it here. So this is there.
Okay.
Okay. But if I need to ask, you know, a friend's number, right, from
Mm.
you, which is, let's say, common friend. So you will only pass that number to me.
Okay.
So it's like that, So because I need to know the multiply value, so you'll say okay, return multiply. You're not returning the entire variable, but you're giving me the value and which I'm able to catch here. But I
Okay.
cannot access to the variable here, right? And all these, like, without double underscore is public. So num1, num2 can actually call, div square you can call. Technically speaking, this should not, this also you cannot call, but Python has not implemented. You'll be able to see. So you cannot see it, but you can still make use of it.
Okay.
Yeah. Okay. So you have that's encapsulation. Okay. And we will again practice this. Now comes inheritance. Okay. Inheritance is something which is very big, and we will spend some time working on it. What it means is you can inherit properties. Properties means your functions and variables. So what you can inherit properties from one class to another. You can inherit properties from one class to another. So you have one class here, another class here. Okay. Now, if you inherit properties from base class to derived class, we say that the class from which you are taking the property is called base class. Okay. And the class in which you are using the property is called derived class. For example, in our case only, we have defined MathOps. Okay. And, we have used all those basic functions. Now, instead of MathHubs, okay, we can create arithmetic ops. We can create trigonometric ops. So in arithmetic ops, we'll have arithmetic operations. In trigonometry, we'll have trigonometric operations. In calculus, we'll have calculus operations. We can create 3 different classes. But for the user should not know there are 3 different classes inside. So I can create math ops, and in math op, I'll do nothing but inherit all the 3 properties from 3 different classes. Okay. So what happens for the user, you see, oh, math ops has everything. Okay. but you can calling from 3 different classes. You are doing this so that you can group arithmetic operations together, calculus operations together, trigonometric operations together. Okay, so that could be one use. Or second use is that, um, uh, when you have one-to-one, okay, what you're seeing is one-to-one, and that's the purpose of one-to-one. Okay, you are grouping them as separate classes, and then you, as a user, okay, user will only see derived entity, okay, or derived class. This is what user will see. Derived will have all the properties from base class. Okay, so all the properties. So when I say all the properties, only the public properties are derived, not private or protected. But protected will also be derived because protected. No, sorry. We're talking about inheritance, right? So protected will also be derived. So that's how you build your family and friend relationship. So it's like they are relatives. Okay, this is like father and this is like son, because you are able to get all the properties of your father, right? So derived will have its own property plus the base class property. So the protected is only accessible in such case technically, but in Python it behaves like public. So behavior is different, but technically protected should only be accessible here. Okay, and you can have different versions here. You can have, okay, let's say this is example. Like you can have some properties for vehicles, and then you have cars. So cars will have its own property plus some properties which are common to all the vehicles. So if you have a vehicle class, then you don't have to rewrite those properties again, right? You don't have to rewrite the properties again. So cars will say, okay, give me all the common properties of vehicles and I'll have my own property. Simple inheritance. One class parent, one class derived. Then you have multiple inheritance, multi-level. You have more than one level. So you can have vehicles, cars, and let's say Tata Motors. So Tata Motors will have unique features, but some features are common for all the cars, right? So those common features, I'll put it in the cars. And again, we have some common feature in vehicle. So car will be able to pull the common features from vehicle, and Tata Motors will be able to pull common features from car. And of course, they'll have their own set of properties. So Tata Motors will be able to access vehicles, okay? So which is protected here will be able to come here. So it's like grandfather, father, and child kind of relationship. Hierarchical is like you have one base class and two derived class. Here it's possible you can have one base class, two derived class, or more than two, more than three. So motorcycle and cars, they are not connected. There is no connection between motorcycle and cars. But yes, there is some connection that, okay, the vehicle properties, okay, maybe there's some common properties between motorcycle and car. Yeah? Yes. So those common properties you can put it in vehicle. And then, so the common property, vehicles might have 10, motorcycle might get only 3, or cars might get only 5. Okay, but there is an opportunity for these two to have common properties, right? So those common will be in vehicles. Hybrid is where it all jumble, all mix. Okay. And then towards the end, we'll talk about polymorphism, what polymorphism means. So I'll stop here today. Tomorrow we'll take examples of inheritance and we'll do. Okay. We'll start with simple, then we'll go to multi-level, then we'll do hybrid, and we'll see how properties are getting accessed by one class and another class.
Okay.
Make sense? Okay. So we'll stop here for today.